So this is sodium aluminate. Right. What we'll be doing now? Now it is free from impurities, but it is not our you can say it is not a formula of our ore. Right. We need to have our concentrated from ore out of it. So what we'll be doing? We'll be reacting this sodium aluminate with water. As you can see, it has metal Na and it has aluminium metal again, the Al. It, metals have the tendency to combine with water to form their respective hydroxides. So what they will, the same they will do here. It leads to formation of NaOH and it leads to formation of aluminium hydroxide. We are not concerned with this NaOH because our ore is an aluminium ore and it is present in this aluminium hydroxide. So what we'll get to do, we'll just in the next step, we'll just heat it, it will expel water and we are left with the ore. So here is our concentrated ore. So that means by the help of chemical separation or by choosing certain kind of chemical, and the criteria for choosing that chemical is that it should react with the ore but not with the impurities. So what happens when we add the chemical with the the impure ore, it combines with the ore but it doesn't combine with the impurities. Then what we do, we just take that compound in which our ore is present, we make it to react with water, right. As they contain metals, so you know that metals have a tendency to react with water to form their respective hydroxides. So as they have formed their respective hydroxides, right. But we are concerned with the aluminium hydroxide because our ore was an aluminium ore and our ore is present in this compound AlOH whole 3, right. And as you get to see that, that it is AlOH whole thrice, that means it has water in it, and you know that the simpler way of removing the water is just by heating. So we are heating it, and what we get after heating, we get our oxide, that is Al2O3, and the water is expelled. So here is a concentrated ore. See, we just started with here Al2O3.2H2, a bauxite ore with impurities, and here we have Al2O3, that is the concentrated ore free from the impurities. So these are, and one more thing, this chemical separation in case of aluminium is being given a special name, Bayer's process. Right. So Bayer's process is actually a chemical separation in case of the aluminium. So this is how you are going to do. So see, there are 4 different methods for concentration. Hydraulic washing, you know that you will be using for heavy ores. Second is froth flotation, you know that you will be using for sulfide ores. Third, we have magnetic separation, you know that we will be using for ores that show magnetic properties. And fourth, the chemical separation, you know that the criteria for using this method for any kind of ore is that we should have a certain chemical with which the ore has affinity to react but the impurities do not react, as you saw in the Bayer's process, that is the concentration of the bauxite ore. So this is how the first step of the concentration of ore is done. So what we have done, see, we have done crushing and grinding, we have done different methods for concentration of ore. Now we will be taking the second step, right. So this is first of all, you just copy it in your copies so that you should be familiar that all those processes which can be involved in the concentration of ore. Then we will be taking up the second step.